Yeah, today's topic we are going to see about linear regression. So we have two types of linear regression. One is simple linear regression and another is multiple linear regression. Before we start the concept of linear regression, let us start to understand what is regression. Okay, so by definition, this is regression. In statistics, regression analysis is a statistical process for estimating the relationship among variables. The focus is on the relationship between a dependent variable and one or more independent variables. So if you see here, let us try to understand first what is dependent variable means, what is independent variable. Okay, so for this, let us take an example. For example, I have a data set like this, like number of study hours. Okay, so let me take in a different place. So I have a data set like this case. So consider this is number of study hours and this is percentage. So if number of study hours are 3, the percentage is around 65. The number of study hours is 4, percentage is around 70. 5, it is around 80. 6, around it is 85, something like that. Okay, so what we are doing, we are plotting a plots. Let me go for a scatter plot. So if you go for a scatter plot, so what I'm doing on x-axis, I'm taking number of study hours. And on y-axis, I'm taking percentage. Okay, so if you see, this is 65, 75, consider like that. This is 3 hours, 4 hours, 5 hours, and all. So if you plot, you'll get a visualization like this. So here it is showing a positive correlation. If the number of study hours is getting increased, the percentage is also getting increased, if you see. Fine. And if you observe, a common sense or a common thing is as the number of study hours is increasing, the percentage is increasing. Okay, so increase in percentage is not making the study hours to increase. So here, what we say, this X, this is independent variable, number of study hours. For example, if you take another example, so I have sales of cool drinks, sales and temperature. As the temperature is increasing, the sales of cool drinks are increasing. So temperature is the one which is causing the sales to increase. Okay. So it is not meaning that if the sales of ice cream, cool drinks are increasing, the temperature will increase automatically. It is not like that. So temperature is the one which is causing the sales to increase. Number of study hours is the one which is causing the percentage to increase. So this temperature, we call it as independent variable. And here number of study hours, we call it as independent variable. Okay. And here dependent variable. So percentage is a dependent variable and sales of cool drinks is a dependent variable. And do remember always we represent the dependent variable with Y and independent variable with capital X. Okay. And if you observe the sales of cool drinks not only depends upon the temperature, it also depends the quality. It also depends upon the location where our shop is located. It also depends upon price also. Okay. So here we have quality, one more independent variable. We have location, one more independent variable. So this is X1, this is X2, this is X3, and price, this is X4. Okay. So if you observe here, we have one dependent variable that is sales and we have multiple independent. Okay. So what you have to understand is always when you find a relation, it would be between a dependent variable and independent variable. or might be between a dependent variable and independent variables. So variables can be multiple as well as. So if you come here, if you see here, when you have one independent variable and one dependent variable, we call it as simple linear regression. And when you have one dependent variable and multiple independent variables, we call it as multiple linear regression. And do remember, guys, regression is broadly classified into two categories. So one is linear regression and another is logistic regression. So we are focusing more. So what is the difference between linear regression and logistic regression? Is in linear regression, what we will find? We will find a numerical output, and in logistic regression, what we find is we find an output which is in a form of a Boolean one, either true or false, yes or no, something like that. Fine. So we are first focusing on linear regression. So in linear regression, we have again two types of regressions, linear regressions. One is simple linear regression and another is multiple linear regression. So what is the difference between simple linear regression and multiple linear regression? In simple linear regression, we have one dependent variable and one independent variable. And in multiple linear regression, we have one dependent variable and multiple independent variables. Okay. So before that, what I will do before we go into the simple linear regression and multiple linear regression, let me open the data sets with which we are going to work. So let me open the data sets. Sets. We have one data set with the name salary. Salary data. Let me open this data set. So this is one data set where you have years of experience, two columns, years of experience and salary. Let me open another data set. We see startups. So this is another data set. Yeah, please confirm whether you can see the text or not, or else I will increase the resolution, screen resolution. Is it okay with you people?
Visible. Yes, sir. It's
Visible,
visible.
right, everyone?
Yes, sir.
Okay.
Yes, sir.
Yes,
Visible,
sir.
sir.
Yes, sir.
Actually, I am checking to another data set. That is the reason I made a font little bit. Fine, yes. So first point, do remember, because we do cover a lot of machine learning models. The first thing what you have to do is when you see a data set, the first point what you have to notice in the data set is what are the different types of variables we have in the data set, what is the type of data that you have in the columns. So if you observe here I have a column with the year of experience. This consists of numeric data, and here I have another column with the salary. Okay, so both consist of numeric data. Fine, that's okay. And next point, what you should identify is you should identify what is a dependent variable and what are the independent variables in that particular data set. So if you see here we have year of experience and one more column we have salary. So do remember, salary depends upon the year of experience you have. Okay, so it does not mean based upon the salary, your year of experience will be calculated. So salary is the one which is depending upon the experience you have. So here in this Excel, we can clearly identify that we have two variables. So one is salary. Salary is a dependent variable. So we notated it with small y, and year of experience is an independent variable. So we notate it as x. So if you see here we have one dependent variable and one independent variable. So that means this data set, this is like we are going to deal with simple linear regression. Okay. Next, if you open another data set, so for example, we have VC starts up here. So in this data set, I have the information. For example, a company is there in US. It is spending this much amount on R&D. It is spending this much on administration. The company is spending this much amount on marketing, and the company is located in New York City, and it is getting a profit of this much. Okay. So I have a data like this. I have almost 50 companies of data where their R&D, administration, marketing spend, state where it is located, and profit what the company is making. That information is over here. Fine. So first point, we should identify what type of data the columns consist of. So R&D, it consists of numeric data, administration, numeric data, marketing spend, numeric data. And if you come to the state, we have three different states here. This is a categorical data. We have three categories. One is New York, one is California, and another is Florida. Okay. And now, after going through this data set, it is clearly visible that the profit is the one which will depend upon R&D. So profit is a dependent variable. So I will denote it as small y. So R&D is the independent variable. I will treat this as X1. Administration, it is another independent variable. X2. Marketing is another independent variable. X3. And state where it is located is another independent variable. X4. Because the companies in New York may get a different profit. Companies in California may get a different profit. Companies located in Florida may get a different profit because it depends upon the cost, how much they have invested to set up the company over there and what are the profits they are getting and all. So even the location is influencing on the profit. That is what you need to understand here. So we have one dependent variable and we have multiple independent variables. So this data set is an example of multiple linear regression. Okay, so that is the thing. And now, if you come to the scenario, now let us go to the simple linear regression data set. So, if you see here, this is the data set what I have. Now, the question is, what is the question is? I want to find out for a person with 3.5 years of experience, how much salary he should get. The question is how much salary he should get. Fine. So let us solve this problem using linear regression, simple linear regression. Okay. So before we go to solve this problem, before we jump into linear regression model, let us try to understand what is the mathematics. See, there should be a strong point, right? Mathematically, like why a person, suppose if we say a person with 3.5 years of experience is getting a salary of 40K. So there should be a strong point and a scientific reason how we can justify that yes, this person with an experience of 3.5 years, he has to get a salary of 40K. So how we justify that one? So we justify that one using the mathematical concept. Okay. So all the machine learning models are based upon mathematical concepts. So even linear regression has certain mathematical concept inside it. So now let us try to understand what is the mathematics for this linear regression. How we can say that a person with 3.5 years of experience is going to get a salary of 40K. Okay. So now for that, what what we do is let us go to the max thing. So let me go here. Okay. So before that, before going to that, let us try to understand this equation. Okay. So we have an equation of a straight line. So equation of straight line is y is equal to mx plus c. So this equation is similar to that one equation of the straight line. Okay. So if you take simple linear regression, so we have a formula y equal to b naught plus b1 into x1. So what is y here? So y is nothing but the dependent variable, and b naught and b1. What are those? Those are the b naught is called as constant, and b1 it is called as coefficient, and x1 What is this? This x1 is nothing but independent variable. Okay. So if in simple linear regression, we have one independent and one dependent variable. So we are taking one independent variable and the dependent variable. So always what is our agenda? Our agenda is to find the value of the dependent variable. Okay. So what would be the value of dependent variable? For example, for 3.5 years of experience person, what is the salary he is going to get? Okay. So here, what is this 3.5? This is nothing but X, that is independent variable. What is this 40K? It is nothing but Y. Okay. So this is dependent variable. So here, using this equation, what we are going to find out, we are going to find out what is the value of y. That is the value of a dependent variable we have to find out. So this is an example of simple linear regression. Now, if you go for multiple linear regression, in multiple linear regression, what you will have? You will have one independent variable and multiple dependent variables. Okay. So if you see here, one dependent variable and multiple. So this is one dependent and we have multiple independent variables. Okay, so fine. Do remember about this equation. Okay, so this is equation. Now what we are going to do is, let us take this data set. Okay, let us take this data set as an example and let us try to derive the mathematical concept of simple linear regression. Okay, so now here what I am doing. So always what we will do, we will take salary on y-axis and experience on x-axis. So this is what we will do always. So salary on y-axis, consider, for example, I have experience, I have salary. So 0 years of experience, a fresher type of thing, getting a salary of 10K. 1 years of experience, getting a salary of, consider it as 20K. This is only an example case. 2 years of experience, getting 30K. 3 years of experience, getting 40K. 4 years of experience, getting 50K, something like this. So this is the data set I have. So what I do is I will plot. So this is 0. So experience, 1 year experience, 2 years experience, 3 years experience, 4 years experience, 5 years experience. So this is 1 year. So this is 10K salary, 20K salary, 30K salary, 40K salary. Think that we are taking a sample data and we are plotting X against Y. Okay, so this is the plot. Fine. So now what I am doing is, let me plot the points. So these are the points. For example, I got different points like this. So here, consider here some 0.3 months or 6 months here, 1 year experience, 2 years experience. So I'm taking some random points case for your understanding. For example, let me take this point, 3 years experience. Let me take this point, 4 years experience. Let me take this point, 5 years experience. Let me take this point, 6 years experience. Let me take this point, 7 years experience. So this is, consider here, 10K, 20K, 30K, 40K likes. So what I'm doing, so this is 1 year experience person. So I'm projecting here. So this is the point. And I'm projecting here. So that means this person with 1 year of experience is getting around 10.2K, something like that. Let me take 2 years of experience person. Let me project it here. So he is getting around 20K, 2 years of experience person. So let me take 3 years of experience person. I am projecting over here. So he is getting around 18K, something like that. Now 4 years of experience person, he is getting a salary around 21K, something like that. Now, 5 years of experience person is getting a salary of 30K, something like that. Okay. Now, 6 years of experience person is getting a salary of 40K, something like that. Okay. So this is the point. So what I did, I had plotted different points. Okay, based upon their salary and experience, I have plotted different points over here. Now, what I am doing is try to understand this. Please concentrate, focus. Now, what I am doing is I am drawing a line like this. I am drawing a line like this, a random line. So, first, what I will do is think that I had drawn one line like this. I had drawn one line like this. I had drawn one line like this. Think that I had drawn three lines. Okay. So this is line one. This is line two. This is line three. Okay. Can you tell me which line is near to all the points? Is line 1 near to all the points, or line 3 near to all the points, or line 2 near to all the points?
L3.
L3, sir.
L3, right? So
L3, sir.
line 3 is the one which is near to all the points. For example, if you take this L2, you see, this is very far away from this point. If you take this L1, it is very far away from this point as well as this point. But this line L3, it is almost touching all the points. So not all the points. It is touching maximum points and it is very near to the maximum points. So now what I am doing, I had drawn different lines. I had drawn L1 line, I had drawn L2 line, I had drawn L3 line. So if possible, I will draw L4, L5, L6 and all. And I will check which line is touching all the points. Okay. So I had observed that L3 is the line which is close to all the points. Now what I am doing, so how I got this line? I got this line with this formula y is equal to V naught plus V1 into X1. Okay, so now I decided that this line L3 is near to all the points. So now after deciding L3 is near to all the points, what I am doing is I am checking its intercept. Okay, so what is the intercept? What is the constant and other things? So think that it is meeting at 30K. After that, what I am doing, I am taking the difference. I am taking the difference. Okay. So if you see here, see, see, this is 30K where it is touching. So these are the points. Okay. And what is the difference for 1 year of experience? Okay. So here, first year experience. So consider it as 2 years, consider it as 3 years. So I am seeing what is the difference. Okay. So it is plus K difference is there. So there is a slope and other things. Now, what I will do is I am drawing this line again. Okay. And think that this this point, these are actual points. So this is yi. So this point is, consider it as y2. This is y1. This is y3. This is y4 and all. So what I'm doing, I'm taking this actual point. So this is actual point. For consider a 1 year experience person, actually he is getting a salary of this much. 10K. So what I'm doing, I'm projecting this point to that line, which is close to all the points. And I'm naming this point as Y1 cap. Similarly, consider this is 2 years of experience. So 2 years of experience person, actually he is getting a salary of 25K here. So what I'm doing, I'm projecting this point. So this point, what it is doing, I'm projecting this onto y-axis. It is showing that 20K. Okay. Now, if you observe, actual point is 25K and when I projected that point to the line and I had seen where it y-axis point is, it is 20K. So what is this difference? This difference is 5K. So what is this difference? Okay, so what is this difference? So actually he's getting a salary of 10K, but according to the line, he has to get a salary of some 15K or 18K. Think that. So there is a difference of 5. Okay. So like this, what I'm doing for every point, I'm calculating. So actually, what is the point? And according to the line, what salary he has to get. So I'm taking YI and YI cap. So two things are there, YI and YI cap. Sometimes YI, suppose if you see here, this YI is 10K, YI cap is how much? 15K. 10K minus 15K. Okay. So what that is? That is minus 5K. So here Y2 is 25K and Y2 cap is 20K. Okay. So that means 25K minus 20K. So here we are getting plus 5K. Okay. So for all the points, we are calculating what is the difference. And after calculating the difference, what we are doing, we are summing them the sum of yi minus yi cap whole square. So we are doing some formula, mathematical calculations. What we are doing for all the points we are taking, and we are summing of sum of vi minus vi cap whole square. Okay. Then what I will do is I will calculate something called as SS residual. So SS residual. So what is this SS residual? It is nothing but that this differences sum whole square. Okay. So if you see sum of yi minus y cap whole square, I get this one after doing the subtraction and all, I use this formula sum of yi minus y cap whole square, and I'm calling this value as SS residual. So SS residual means sum of squares of residual errors. So that is called as a residual errors. Why we call it as errors? Because according to the line, this is the salary they have to get, but they are getting this much. So it is treating it as an error. According to the data set, this is the salary they are getting, but according to the line, this is the salary they have to get. So that is an error. So that's the reason we call it as sum of squares of, because we are squaring and summing that. That is the reason we are calling it as sum of squares of residual errors. Okay. Now after that, what I'm doing, I'm calculating something called as Y average. What I'm doing, I'm calculating something called as Y average. So how we will get Y average? It is very simple. Y average. So suppose for example, this is 0, this is 10K, this is 20K, this is 30K, this is 40K, this is 50K. So what is this Y average? 10K plus 20K plus 30K plus 40K plus 50K by 5. So we get around 150 by 5. Again, we are getting 30K. So what is this average? This average is 30K. So now what I'm doing at 30K, I am drawing a line again. At 30K, I am drawing a line again. Now again, what I am doing from this point, I am projecting here. From this point, I am projecting here. From this point, I am projecting here. So suppose, for example, this is 40K. So what is this point? This point is 30K. So what is the difference? Difference is 10K. So this point is around 10K. This point is 30K. So what is the difference? 20K difference is there. Okay. So now again for all the points, after drawing this Y average line, for all the points, what I am doing, I am calculating the difference. And that difference I am again summing up. So if you see this is YIA, this will be YI average. Okay, so for example, this is Y4, this is Y4 average. So again, what I'm doing, I'm summing them and I am squaring the difference. And I'm calling this as SS total. So what I'm calling it as SS total errors. Okay. So now I have two mathematical derived things. One is SS residual errors and SS total errors. So this is again a error it is treating. Consider average errors. Okay. Two things I got. One is SS residual and another is SS total. Now what I am doing, I am taking these two things, SS residual and SS total, okay, and I am calculating something called as R square. R square equal to 1 minus SS residual by SS total. So this is the formula for R square. So what is that? SS res 1 minus SS residual by SS total. So we got some value, we will get some value, something called as R square. So when we have R square, so if you want to make it only R, so if you want to make it only R, what we have to do? We have to do a root of 1 minus SS residual by SS total. So what is this R? So this R, the line which have the highest R. So what we are doing for every line, for example, if you see here, I am calculating, I am drawing a line like this, L1. I am drawing a line like this, L2. I am drawing a line like this, L3. I am drawing a line like this, L4. So for all these lines, we are calculating this R value, all the lines. And finally, we take one line. Suppose this is L5. So a line which has a highest R value. For example, this line has a value of 1.0. This line has a value of 1.5. This line has a value of 1.6. This line has a value of 1.7. This line has a value of 0.9. So what we'll take? We'll take that line which has highest R value as the line which is close to all the points. Okay, so actually we are not drawing lines and we are checking. Suppose if you need to draw a line, for example, if I want to draw a line like this, if I want to draw a line like this and check whether it is touching all the points and all, if you want to try again a line like this and checking whether it is near to all the points, but like this we draw multiple lines and we can't check hundreds of lines like this. So what we do mathematical calculation and how to identify which line is nearest to all the points. To identify which line is nearest to all points, we have something called as R square value. So we find out the line which has highest R square. So for example, this line has 0.9 square, 9 R square value. This has uh, 0.7. This has 1. This has zero point 0.5, it has 0.6. So in this line has highest R square value. So the line which has the highest R square value is the line which will be near to all the points. Okay. And do we need to do manually these calculations and all? No, we are not going to do manually these calculations. So who is doing these calculations? All calculations. And who is giving us the information that this line is the perfect line, and based upon that line, this should be the salary of a person with 3.5 years of experience. Our algorithm, linear regression, is going to do that one. So internally, the linear regression model, when you build the model, okay, so it is taking the data and it is drawing 100 number of lines, and for each line it is calculating the R square, and finally it is picking the line with highest R square, and based upon that line which has the highest R square, it is justifying for a person with 3 years of experience how much salary he should get, or for a person with 2.5 years how much salary he should get, and something like that. Okay, so this is the mathematical funda behind linear regression. Okay, got my point? So everyone, have you understand? Please confirm me with NS. Don't get confused.
Yes,
So
Yes,
you
sir.
should know what is the basic mathematics,
Yes,
yes, sir.
sir.
right? Suppose we are saying that For a person, 3.5 years of experience, he should get 40K salary. So what is the base for that? The base is the line with highest R square. So who is deriving that one, or who is framing that line with highest R square? Linear regression model is doing all internal calculations and giving us the highest R square line. And based upon that line, it is giving the information for a person with 3.5 years of experience, how much salary he should get. Okay, so got the basic mathematics of linear regression? If so, please say with an S, pin with an S, pin
Yes,
with an
sir.
S.
Yes, sir.
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Sadiq, have you understand?
Yes, sir.
Okay. Hussein, Basha, Mahalakshmi, Mukesh, Prashant,
Yes,
have you
sir. Yes, sir.
understand Prashant? Very
Yes,
clear.
sir.
Rakshita, have you understand Rakshita? Okay. Rakshita might be in Puja, Varalakshmi Puja. Okay. Sampath Reddy,
Yes, sir.
fine. Okay, fine. There is a thing. Now, okay. Yeah, fine. Rakshita answered. Okay, Rakshita. So that is the thing. Now you have understand what is the mathematics, right? So now you have understand. Let me stop.